So what is an economizer and how does it work? Well, Economizer is a mechanical cooling system feature that saves a lot of energy and saves a lot of money. Who doesn't like to save money? Economizer is a feature or option that can be implemented on air handlers and package units, which are two types of mechanical cooling systems. With Economizer, these type of equipment can take advantage of cool outside air to save energy. Let's look at this in a little bit more detail. Normally, an air handling unit or a package unit circulates the indoor air to cool it. The fans of these units bring in or return the room's air into the unit where it gets cooled down by a cooling coil. But when the outside air is cool enough, the units stop circulating the room's air, and instead it starts to supply outside air into the room. Since the outside air is already cool, the compressor of the mechanical cooling system can operate in low capacity or completely stop working. And that's how energy is saved with an economizer. As you may have guessed, by supplying 100% outside air, we are pressurizing the room, and we need to somehow relieve this extra pressure. There are three methods to relieve this extra pressure. The first one is using a relief damper. This method is mainly used for small systems. In this method, an automatic or barometric damper opens up when the system goes into the economizer mode. With this method, the room will still be at a slightly positive pressure, but this positive pressure will not cause any issues such as excessive noise in the rooms. Using a dedicated exhaust fan is the second method. In this method, an exhaust fan, which can be part of the air handling unit or package unit, starts to operate when the system goes into the economizer mode. By exhausting the room's air, this fan relieves the pressure from the room. The third method is changing the system's return air fan into an exhaust air fan. This method is only applicable to systems that have both supply and return air fans. In these systems, when the unit goes into the economizer mode, the mixed air damper completely closes and the exhaust damper opens. This turns the return air fan into an exhaust fan. Here's the biggest question about the control of economizers. When does the mechanical system need to switch into the economizer mode? There are multiple methods for the control of economizers. These methods are listed in energy standards and energy codes such as ASHRAE 90.1 and International Energy Conservation Code. But here, I'm going to focus only on the prescriptive methods that are allowed by ASHRAE 90.1 because this standard is widely adopted by energy codes. The four methods are shown here on the screen, and I'm going to go over each of them. The first control method is fixed dry bulb temperature. This is the simplest method. In this method, the controller compares the outside air temperature to a programmed high limit shutoff value. If the outside air temperature is above this high limit, then the controller disables the economizer. Let's look at Phoenix International Airport on March 15th of 2022. If we set the economizer's high limit shutoff temperature to 75 degrees Fahrenheit, then the economizer is active in most of the hours on March 15th. As you can imagine, this saves so much energy for the airport's HVAC system. The second method is differential dry bulb temperature. In this method, the controller compares the outside air temperature with the return air temperature. And if the outside air temperature is above the return airs, then the controller disables the economizer. The advantage of this method is that we are sure that the outside air will never increase the cooling load, even when the occupants lower the room's cooling set point. As an example, let's look at a house in Phoenix, Arizona on March 15th of 2022. Let's assume indoors temperature set point is 74 degrees Fahrenheit. The mechanical cooling system turns on to cool the room when the room's temperature or the return air temperature increases to 75 degrees Fahrenheit. Now, the controller activates the economizer whenever the outside air temperature is below 75 degrees Fahrenheit. But what if the indoor set point changes to 70 degrees Fahrenheit? This is when we can see the advantage of differential dry bulb temperature over fixed dry bulb temperature method. With the differential temperature method, the economizer gets activated when outdoor air is below the return air, which is at 71 degrees Fahrenheit. But with the fixed dry bulb method, There are times that the economizer brings in outside air that is at a temperature above the return air temperature, which means that we are increasing the cooling load instead of decreasing it. The third control method is fixed enthalpy with fixed dry bulb. In this method, the controller compares the outside air's both enthalpy and dry bulb temperature with programmed high limit shutoff values. The controller disables the economizer when the outside air's enthalpy is above the high limit enthalpy, or it disables the economizer when the outside air's dry bulb temperature is above the dry bulb's high limit. This control method is very useful for projects in regions with high humidity. In these regions, the economizer may add unwanted humidity to the indoor spaces by bringing humid outside air, even when that outside air's dry bulb temperature is below the high limit shutoff value. But this issue can be eliminated with this control method, which considers enthalpy too. On the chart below, the highlighted area shows the outside condition that is cool but too humid to be used by the economizer. The fourth control method is differential enthalpy with fixed dry bulb. This is the most complex method, and in theory, this is the most accurate one because it provides the maximum energy saving and maximum comfort for people. In this method, the controller compares the outside air's enthalpy with the returns air enthalpy, and also outside air's dry bulb temperature with a programmed high limit shutoff temperature. The controller disables the economizer when the outside air's enthalpy is above the returns air enthalpy, or when the outside air's dry bulb temperature is above high limit shutoff temperature. With this method, the economizer never brings in outside air that is warmer than the return air. The fixed dry bulb high limit value prevents very dry outside air that has a temperature that is uncomfortable for humans or occupants to be used by the economizer. Such condition is highlighted in this chart. Now you may ask where or when each of these control methods should be used. The answer is easy. The control method should be used or should be selected based on the project's climate zone. Both ASHRAE 90.1 and International Energy Conservation Code have tables that show which control method should be used for which climate zone. One thing to keep in mind about different control methods is sensor accuracy. Complex control methods require multiple temperature and enthalpy sensors. Each of these sensors has error, and the sensors' combined error may result in poor performance of the economizer. Because of this issue, ASHRAE 90.1 has requirements for sensor accuracy which must be followed by all economizers. Thanks for watching this video. If you have any question, post it in the comment section down below and I'll make sure to respond to it. Also, if you found this video helpful, don't forget to hit the like button and subscribe to AEC Learn.